Natural physics is a concept I developed that explains in down-to-earth scenarios how the principles of physics could have come about from observing nature. Each episode begins with a scenario followed by an example to illustrate the application of these principles in futuristic research at the frontiers of science, such as my astrophysics research, and then concludes with an exploration of how these same principles could have very well been used by ancient cultures and civilizations. Mathematics is naturally encountered and incorporated as the exciting and fun tool of science that it is. Science is the window into our amazing world of nature, and mathematics is the tool to open that window. Natural physics encompasses current, futuristic, and ancient physics, and ties them together by the principles of physics that are common threads running throughout each.
Hey, August. Okay, even people like us that won't see a total eclipse, you'll still see a partial eclipse. It'll get dark, and it's really cool. I hope you get a chance to experience a total eclipse. I hope to get a chance to experience a total eclipse one day. But partial is cool too. Speaking of special events, I want to go back. I want to do a go back to the green comet real quick because we were talking about that in our last session. And what I wanted to show you was something I came across. Okay, check this out. Okay, you see what I'm pointing at right here? Mm-hmm. Okay, so on the internet, it shows that on February the 11th, which was when Tears and I went to the volcano with that special group with the professional astronomers to see the green comet, February the 11th, it was a Saturday, right? So evidently on February the 11th, that was the conjunction of the green comet with Mars, meaning that's when the two were very close together. So you see there's Mars and there's the green comet. So I always wondered why that trip was on February the 11th, not the 10th, not the 12th. I wondered, and there's the answer, because on February the 11th, there was that special conjunction of Mars with the green comet that made it easy for those professional astronomers to locate the green comet. And I think you might remember that I told you that when Tears and I looked through the telescope on top of the volcano, we saw two dots of light. In fact, Tears has said it was looking like two pinpoints of light. So that's what we were looking at, those two bright spots. One was Mars, and then the bright spot above it, that was the green comet. We saw something that hadn't been around for 50,000 years. And you know what? Hey, Juliet. Hi, Juliet. Okay. Hey there. And you know what, August? Because of the gravity between the comet and the sun and the way our solar system with the gravitational forces, evidently, August, it's very possible that the green comet will never come back. Now, the eclipse that's coming up. First of all, do you have any more questions about the green comet at all? No. All right. Now, the solar eclipse coming up. Here's the video that I wanted to show you about the eclipse. Now, remember from last episode that this shows how eclipses and lunar eclipses happen. Okay, so the two important points that come into play when predicting a lunar or solar eclipse is what's called the lunar nodes. And these are the points that the moon crosses the elliptical plane. Now, the elliptical plane, that's the plane that the Earth and all the other planets except Pluto orbit the sun. Okay? So that elliptical ring that you see the moon going around, notice that it seems to be at an angle, right?
I mean, you figure the elliptical plane is the same, the point on the horizon where the sun comes up and comes down. If you draw a line between those 2 points, you got your elliptical plane. So the moon actually orbits the earth at a 5-degree angle. So it crosses this elliptical plane 2 times. Okay? So it turns out that these 2 lunar nodes, the point on the elliptical plane at a time that's close to one of the nodes, that would say that you have a high probability that there's going to be a solar eclipse. And if you have a new moon that's going to occur anywhere close to one of these nodes, that's going to be a lunar eclipse. All right? So basically, if you have a civilization that keeps track very precisely of when the moon comes up and goes down on the horizon, you start to notice things. Okay? You start to.
Okay, that's good. I wanted to ask you, August, how was your Easter? Did you have a good Easter? We still have some Easter eggs left from our Easter, okay? Just not many, but yeah, Tears and I, we made every Easter we make Easter eggs. So that's the path of the eclipse. And you're in Edmonton, California, Edmonton, Canada, and so you see, you're not going to be in the path of the total eclipse, but you will still be close enough that you'll see the effects of it. So I'm down here and I'm not in the path of it either, excuse me, but I will see the effects of it. So both of us will be able to see the sun getting darker, the sky getting darker, I mean, as the moon starts to cover up some of it partially. And that's going to be so cool. The last time this happened was in 2017, 7 years ago. So it's going to be great. It's going to be so interesting, so exciting. And you know what, August? There's actually airplane flights that people are going to be on where the airplane, it flies in the shadow of the total eclipse so that people can look out the window of the plane and see the eclipse for a good while. And there's also going to, isn't that cool that a airplane is going to follow the path? And there's going to be cruise ships because see, it starts the eclipse at 12:30 our time. It starts out here in the Pacific Ocean. So there's cruise ships that are going to cruise within the shadow of the eclipse, and people can stand out on the deck and see the solar eclipse for a good little while, right? Of course, they'll have to stop, right about here, right before you get to Mexico. And then there's probably cruise ships here that will leave from, I guess that would be, it's north, Newfoundland, maybe. I think that's Newfoundland. And they're going to cruise out into the Atlantic Ocean in the shadow of the eclipse, and people will be able to see it to see it for a while. Okay, so as the eclipse comes up from the ocean, it's going to go through Mexico and then Texas, a little bit of Missouri, a little bit of Illinois and Indiana. It's going to go through a lot of Indiana. It's going to go through a lot of Ohio, and then New York, and then up into Canada, Montreal, and then it's going to head on out into the ocean. Hey, August. Okay, all right, let's rock and roll. All right, now I want to get back to talking about forces and the force of gravity, okay, that we were talking about before. And you remember how Balo was teaching his little brother Dini about force and how it's equal to mass times acceleration. And then Osco was talking about how force is equal to mass times gravity, which is your weight. You remember that? Okay. Now, Deanie, he learned very well from his big brother. He sure did. And I mean, it's so cool because Balo learned from his big brother Osco, and then Deanie learned from his big brother Balo. Deanie learned very well in that lesson. And I'm going to play a video that demonstrates just how well he learned. Okay. There. Deanie learned real good, didn't he?
No.
Deanie's saying, I learned your lesson very well, big brother. And Balo's saying, you sure did. You sure did, little brother. Now, you saw the force that Deanie was applying to Balo, right? Yeah. So, yeah, you remember when Balo taught Deanie that lesson about force is equal to mass times acceleration. Deanie learned it very well. Now, I remember your goal to plan a mission to the atmosphere of Jupiter, correct? Okay, okay. And I know you're still working on that. That's an awesome, awesome mission. Now, even though
I kind of do want to still go, but I kind of also don't.
what did you say?
I kind of still do, but I also kind of don't.
Okay, now why kind of don't?
Because I just wrote a book with Mr. Bruce that it's about going to Titan.
The Titan. All right, okay. Yeah, Titan. Hey, Titan that's great too, right? That Titan is a very interesting moon. There's a lot of scientists that are very interested in Titan. And I think some actually have suggested that some type of life might be found on Titan, I believe. So, okay, well, I tell you what, if you keep going with your idea to send a mission to Jupiter, what I'm going to tell you, it applies to if you also have a mission to go to Titan. When Galileo was launched, it went out as far as Venus, and then Venus's gravitational field whipped it around, gave it energy, speed, and it came back to Earth. And then Earth's gravitational field grabbed it, whipped it around Earth, flung it further out into space. And then 2 years later, it came back to Earth. Earth grabbed it one more time with its gravitational field, whipped it around the Earth, and headed it for Jupiter. I want to play you some of this video where I was demonstrating how Galileo gets helped out by the gravitational field of Earth and Venus to get to Jupiter, okay?
Way across, okay? Okay. You see how you have to pull it? You have to keep it. If you stop pulling on it, it's not going to keep going in a circle, okay? So that's what the gravitational field of the Earth does. Everybody, the force that she's pulling on it is equal to the mass of that ball times how fast it's going. Okay, next person. Next person. You can thank you.
Give it to someone else.
Yeah, give it to the next person. Okay, now swirl it. Okay. Okay, you're the Earth. The ball is Galileo, and the string, that's the force of gravity that you, the Earth, are exerting on Galileo to keep Galileo going in orbit. Now, let it go. Let it go. Just twirl it and let it go. Just
Salida.
okay.
Woo!
Okay. So
On the roof. There's Galileo.
well, he's Galileo gravity. Earth Galileo gravity. Okay. All right. Go. Excellent.
Woo!
On the way to Jupiter.
Yay!
It's ready. You're gonna let Galileo go towards Jupiter. Right on. Pulls on Galileo. Earth is going to use its gravity to give Galileo more and more and more energy. The more times Galileo goes around Earth, the more energy it gets. It's got enough energy to break away. So you feel the force that the Earth has to apply. You're the Earth, you got to apply a force to Galileo to keep it going in a circle.
Woo!
All right, all right, all right. Thank you. All right. Galileo. Earth is going to use this gravity to keep Galileo going in a circle, in a circle, in a circle. Energy, more energy, more energy, more speed, more speed. And then after Galileo goes around Earth so many times, it's got enough energy to get to Jupiter, and it's going to break away and go to Jupiter. Okay? Okay, so spin it. You're the Earth. You're using gravity to keep Galileo going in a circle, and then you're going to let Galileo go towards you. Okay? Okay, so just spin it. Yeah.
Woohoo!
There you are. You're the Earth. Galileo.
Más alto.
Okay, there you go. There you go. Right on. Thank you.
Did you enjoy that? So you see, that's what Earth and Venus did to Galileo. They whipped Galileo around themselves with their gravitational field and helped it get to Jupiter, right? You see how you can get more energy? Okay. So with your upcoming mission to Jupiter or Titan or both, that's a main principle of physics that we're going to have to keep in mind. You're going to have to keep in mind the force of gravity, okay? Now, okay, a supernova is a star that has exploded. And again, you're talking about the force of gravity, August. In a star, the theory is that you got the inside, which is burning energy and trying to expand the star. And then you got the gravity of the star that's trying to cause it to collapse. And the two keep going back and forth, trying to balance each other. And then when the gravitational field is not enough to contain the burning heating in the middle of the star, it explodes into a supernova. So what the James Webb Space Telescope has discovered is that in the middle of this supernova that exploded millions and millions of years ago, there's a neutron star, which is a very, very, very dense, compact star. Very, very dense. And sometimes, instead of becoming a neutron star, a black hole is formed in the middle. So the data that I'm going to be looking at with from the James Webb Space Telescope. You see where it says supernova 187A? These three are the observations that got this image. That's the data I'll download to start looking at this. Is there anything you would like to ask me about physics? Okay. Okay, now we're getting ready to have a solar eclipse. And to be able to predict when a solar eclipse is going to happen, that means you have to know the path of the sun and the moon and the earth through outer space, right? So imagine ancient civilizations being able to do that thousands of years ago. Okay, now there's a picture of those two spheres, and you can see the sun coming up, right, in alignment with those two spheres. Right? Guess what, August? This only happens on the spring equinox. That's the only time of the year when the sun will come up directly aligned with these two spheres on the spring equinox, which this year was March the 19th, right? Remember we did our spring equinox show? Yes,
Yeah.
yes. So when we did that show earlier that morning, around 5:30 a.m., the sun came up right aligned with these two spheres. So imagine, August, the knowledge and the number of observations that would have to take place for some people, nobody knows exactly who, thousands of years ago, to put those spheres where they would show when the sun comes up and would let them know when the spring equinox occurs, right? Isn't that cool? And as we said, you said for you, the spring equinox means, or springtime means time to change your clock, right? Set it forward. But also it means that's the time to plant your crops, springtime, right? So you can have a successful harvest, so you can have food to survive. Tears and I were there at that site. Okay, there's the same two spheres in the ground. And then one picture, I don't know if I've ever showed you, but this is a picture of me next to a sphere that is located, it was removed from its original location. And I did a show where using physics and mathematics, we calculated that that sphere probably weighs about 10 tons, okay? About 10 tons. These ancient peoples, because of these two spheres, it shows they kept track of the movement of the sun and could also predict when a solar eclipse was going to happen. So the ancient civilizations, their knowledge is tied in to our current knowledge, August, and we're going to be exploring both of these through natural physics, okay? And learning physics and the fun tool of math along with it, okay? Remember FAT, physics with attitude, enjoying physics as the window into our amazing world of nature and mathematics as the tool to open that window. Mathematical equations, right? F is equal to ma. Force is equal to mass times acceleration. F is equal to mg. Force is equal to mass times gravity, which is your weight. Okay, all right. So August, I will see you next time. Same fat time, same fat channel. Okay, August. I hope you had a good time. Did you have a good time? Okay, let me ask you this, August. What moon, Titan is the moon of which planet?
Saturn.
Excellent. And is Titan the largest moon of Saturn?
I think so, yes.
Yes, as far as we know, it is. If you have any questions in the meantime, just let me know. Okay, all right. Bye now. Okay, bye. Okay. Okay.